So this is the 2015 Leaving Cert Higher Level Paper 1 and we're looking at question number 6. Part A, Donna is arranging a loan and is examining two different repayment options. One, Bank A will charge him a monthly interest rate of 0.35%. Find, correct to three significant figures, the annual percentage rate, APR, that is equivalent to a monthly interest rate of 0.35%. Okay, so I've taken this formula here from my tables book for interest or compound interest, which is f equals p times 1 plus I to the power of t, f being the final value, p being the principal, I being the interest rate, and t being time. So if I look at the APR, the annual percentage rate, which is what I'm trying to find. So the annual percentage rate, if I use this formula, I will get f is equal to, let's just take a principal of 1 to keep things simple. It gives me 1 plus I to the power of t. Now t in this case is 1 year, so we're just going to look at 1 year. So that gives me 1 plus I, where I is the interest rate that we're looking for. So if I now look at this for monthly percentage rate, I've got f is equal to same principle again, bracket 1 plus my I value for the monthly percentage rate is 0.35%. Now 0.35% as a decimal would be 0.035. You divide by 100. So that's what goes in here, 0.0035. And my time is going to be 12 because there's 12 months in 1 year. So when I put all of this here into my calculator, it gives me an answer of 1.04218. Okay, so I know that these two things then are equivalent, so I'm going to let 1 plus I equal 1.042818. I'm going to bring that 1 here over to the other side. Becomes a negative, so I get my I is 0.042818. But they want it as a percentage, the annual percentage rate. So to convert this to a percent, I times by 100. That gives me 4.2818. But they did say to round it to three significant figures. So three significant figures. I look to the fourth significant figure. Does this one affect the 8 in front? The answer is no. So it's 4.28%. That's my APR. Okay, part B, or part A2. Bank B will charge him a rate that is equivalent to an APR of 4.5%. Find, correct to three significant figures, the monthly interest rate that is equivalent to an APR of 4.5%. So again, using the same formula, I'm going to look at APR and the monthly interest rate. So for APR, taking a principal again of just 1 to keep it simple, 1 times 1 plus the interest rate for APR is 4.5%, and 4.5% is 0.045 as a decimal, which is what we use in the formula. So we're putting the 0.045 in there. And again, this is the time for us will be 1 year. So we'll just take 1. For the monthly percentage rate, monthly interest rate, we're going to assume a principal of 1 again, bracket 1 plus the I this time that we're looking for MPR, the monthly interest rate. And again, this is to the power of 12. So that just gives me 1 plus I to the power of 12. And up here, I forgot to work this out, but when you do all this in a calculator, you get 1.045. So, again, we know that these two things here are equivalent. So we're going to let them be equal to each other. So when we do that, we get 1 plus I to the power of 12 is equal to 1.045. If you take the 12th root of both sides, you get 1 plus I equals the 12th root of 1.045. So that gives us 1 plus I equals the 12th root of 1.045 is 1.0036748. And we're looking for I, so I'm going to bring this 1 over here to become negative. So we're left with I is equal to 0.0036748. But we want it as a percentage, so we're going to times this by 100. So our answer then is 0.36748. And again, they want it correct to 3 significant figures. So I'm going to look to the 4th significant figure. Does this 4 affect the number in front? No, it doesn't. So the answer then is 0.367%, correct to 3 significant figures. And that's the end of A part 2. Part B, Donna borrowed €80,000 at a monthly interest rate of 0.35%, fixed for the term of the loan, from Bank A. The loan is to be repaid in equal monthly repayments over 10 years. The first repayment is due 1 month after the loan is issued. Calculate correct to the nearest euro the amount of each monthly payment. Okay, so again, I've taken the formula here below from the tables book. This is for mortgages and loans, equal repayments at equal intervals, and it calculates the repayment amount. So I'm going to use this formula here, and I'm going to substitute into this. So I'm going to work out my values first. I know that A is the amount advanced, which was 80 grand or 80,000. Then you've got the I value, which in our case is 0.35%, but we're going to write it as a decimal. 0.035, that's our I value. And the only other variable then is T. So T is going to be our time. Now, because this interest rate is given in months, we need the time in months. So if it's 10 years, that's going to be 10 years, 12 months in each year. So it's 12 by 10, which is 120. So substituting all of these then into the formula, we get OR is equal to 80,000 by the fraction I, which is 0.0035 times 1 plus I again, 0.0035. That's to the power of 120. And that's all over 1 plus I to the power of t minus 1. So that's going to be 1 plus I again, 0.0035 the power of 120 again, and then that's going to be 1 subtracted from it. So when I put all of this then into my calculator, I get a repayment value of 817.59, correct, the nearest cent, but then I want it correct to the nearest euro, so that's going to be an R value of, to the nearest euro, we look to the first digit after the decimal. Does this affect the one in front? Yes, it does, so it's 818 euro is our repayment. And that's the end of part B and the end of question 6.